I'm Anil Kumar sharing with you a very interesting test question based on application of derivatives. The question here is, determine the equation of a polynomial that has turning points at 1, 6 and 3, 2. Now there are two turning points, so we'll try to go for a cubic equation. The general form for a cubic equation is y equals to ax cubed plus bx squared plus cx plus d, right? Now there are four unknowns here. We can actually find these four unknowns since we can form four equations. So we are going to get two equations from the given points and then two equations from the information about turning point. Turning point means what? Turning point means that the derivative is equal to 0, right? So that is going to give us two more equations. So we'll have four equations to solve. So it's more or less a question based on simultaneous equations, right? So let's begin by writing the first two equations by using these 2 points. So if I substitute 1 and 6, what do I get? Y value being 6, x being 1, we get a plus b plus c plus d, right? So we get one of our equations. I'll call this as our equation number 1. Now let's substitute 3 and 2. That means x value is 3, y value is 2. So we get 2 equals to 3 cubed is 27. So we get 27a, 9b plus 3c plus d. And we'll call this as our equation number 2. Now from these two equations, as you can see, we can eliminate d. So if I do, let us say equation 2 minus 1. Let's say equation 2 minus equation 1. Then we could eliminate d. 2 minus 1, we get minus 4 here. 26a, 8b plus 2c. Let's divide it by 2. So we get minus 2. 13a plus 4b plus c, right? So this equation, we can number this equation as our equation number 3, which we got as a result of working with equation 1 and 2. Now, let's look into the derivative part. Okay, so let's go to this side now and work on the derivative. So if y is equals to ax cubed plus bx squared plus cx plus d, what is the derivative equal to? 3ax squared plus 2bx plus c. That's the derivative. And we know this derivative is 0 at x equals to 1 and also at x equals to 3 since they are turning points, right? So at x equals to 1, this is 0. So we can write 0 equals to, substituting 1 here, we get 3a plus 2b plus c. Correct? Let's call this as our equation number 4. Now, let us substitute x equals to 3. That also will give us 0. So we get 0 equals to 3 squared is 9, 9 times 3 is 27, so it is 27a, 3 times 2 is 6, 6b plus c. So that gives you equation number 5. Now from these two equations, we can eliminate c, right? So we can eliminate c. So let's do 5 minus 4. So we'll do 5 minus 4. Equation number 5. Take away equation number 4. So we get 0 equals to 24a plus 4b. Dividing by 4, I could write this as 6a plus b. Right, so we get the value of b in terms of a. We could also write this as b equals to minus 6a. Okay, we'll call this as our equation number 6. Now, we have two variables. We need another equation to solve with two variables. So we can look into the combination of equation 4 on this side with 1 on that side. Rather, let's go to 3. Now these equations we can eliminate c and get the second equation in terms of a and b. Okay, so now we'll work with equation 4 and equation 3. So let's do equation 3, take away equation 4. Right, so now we are working with this equation and this equation. Okay. We want to do 3 minus 4. We want to do 3 take away 4. So if I do 3 take away 4, I get this as minus 2. 13 take away 3 is 10, a. 4 take away 2 is 2, so plus 2b. We can divide by 2, so we get minus 1 equals to 5a plus b. Right, so we get this equation. Let's call this equation as 6. We already have 7. Correct. So we could substitute b equals to minus 6a and solve. So we know what b is. B is minus 6a. We'll substitute this value of b here in equation 7. Right. So what we get is minus 1 equals to 5a and b is minus 6a. So we'll write minus 6a. So that gives us minus 1 equals to minus a, and that means the value of a is 1. Correct. So now we have one of the coefficients. The leading coefficient a is 1 for us. Okay. Now once we know a, we can find b, c, and d. So let's find different values of b, c, and d. We have a equals to 1, b is minus 6a, so b is equal to minus 6a, so that means b equals to minus 6, right? So we have a and b for us. So we have a equals to 1, let's highlight it with the different ink, and b is minus 6. How do we find c? The best equation to take for c will be equation 4 itself, right? So that's a neat equation. So from here, from equation 4, we can get c as equal to minus 3a minus 2b, right? So that gives us minus 3 times 1 minus 2 times minus 6, which is minus 3 plus 12, and that is 9. So we get c as 9. Okay. So we get c equals to 9. To find d, I can use the very first equation. D is equal to 6 minus a minus b minus c, right? So d is equals to 6 minus a minus B minus C, which is 6 minus 1. B is minus 6, that makes us plus 6, and C is 9 for us, minus 9, right? 6 plus 6 is 12, take away 10, leaves us with 2. So we get C as equal to 2. So this is the value of D, right? Okay. So now we know all the coefficients. We can write down our equation, which is y equals to A is 1, so we have x cubed. B is minus 6x squared. C is 9 plus 9x, and D is 2 plus 2. So that is the answer. That is how we can get our cubic equation from the given conditions, right? Since the leading coefficient is positive, we do have a graph which is going kind of like this, right? So what you will notice is that at the first turning point, which is right there, we have a maximum, right? So you notice here that in this particular situation, we'll have maximum at 1, 6, and we have minimum at the second turning point, which is 3, 2, right? So that is what we'll get. So I hope you now understand how to find equation from given conditions. Feel free to write your comments and share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching, and all the best.